All right, let's show normal boot up. All right, we are up and running, and there is no SD card in the SD card slot. Let's turn it off. And now I've got an SD card. Plug it in. And let's boot it up off of the SD card. All right, and there we have it, booting straight into Raspberry Pi OS on the SD card only. And that is the current state of the art right now. Okay, so I promised we come over to the bench and do a little bit of discussing of what's going on with the state of affairs. We have this GitHub repo right here, and I'm trying to make this a central location for the Toads hacking of the X6100. I have a couple of things up here. I have the high-res photos. I have some custom hacked firmware, including the Open Transmit firmware that you guys are looking for. And then I have a roadmap down here. This is an open repo and it is ready to be contributed to. And right now, what I'm trying to work on is to get this thing to boot Raspberry Pi OS from the SD card natively. And I showed you that it's working. However, I can't recreate the working status. I went out and I bought a couple of extra SD cards with the goal of trying to make a distributable image. And for some reason, it's like a work of black magic to get this thing to boot off the SD card. So that's step one. I'll show you a little bit more about that in a second. Once that is done, I want to be able to have the Wi-Fi drivers installed for the built-in Wi-Fi card. I believe it's hooked up through GPIO pins. Not 100% sure yet. It doesn't show up as a regular device, but it's hard to tell because the kernel that is included with the X6100 doesn't have support for like your LSPCI tool or something along those lines. So it's hard to even tell how stuff is connected yet, which is why I want to get this boot natively on the SD card and then get the latest version of the regular Linux kernel, not the scaled down version of the Linux kernel. And then you also saw that the screen on the radio is tilted 90 degrees to the right. I want to obviously bring that up. It's an 800 by 480 screen. And if you've used the Raspberry Pi 7-inch official touchscreen display, that is the same screen resolution. So you're probably already familiar with how that's not really going to work unless we do some magic. I've got some ideas for it. And then once we get all of that done, I want to start working on loading up some ham software on it. The reason why we decided to go with Raspberry Pi OS is because there is a lot of development behind it in the ham community already. There is DigiPi, there is Build-A-Pi, and there is HamPi, to name three right off the top of my head. So that proves that the Raspberry Pi itself is fully capable and has all of the development already done. While we're in the GitHub repository, there are issues tabs and there are wiki tabs, and feel free to contribute to this. And if you have any trouble contributing to it, leave me a message and let me know what needs to be fixed, and we will make this thing move forward. Let me show you what I'm talking about with the SD card. All right, now we're set up with Build-A-Pi from KM4ACK, and I have the SD card installed. Let's pull up GNU partition editor, gparted. Let's switch to the external SD card. And the radio itself is very configurable and can boot off of a lot of different boot media. If you're familiar with U-Boot, this is a version of that open firmware that we're working with here. So I have one generic flat partition. This was just a demo to try and get it to work. There is a way to get it to work with FAT16 because that's how Zygoose firmware is set up. And I don't see any reason why it wouldn't work with FAT32. This was just an attempt to get it to work. It does work, and I can't replicate this, so I got to figure out why. So this is an ext4 partition, and it's on a 32 gig SD card, and we're using about 5 gigs. So it'll compress down nicely once we get to that point. We just aren't there yet for whatever reason. So there's nothing special going on with this boot partition. I just can't recreate this. So if anybody is a U-Boot legend, let me know, and we will take it from there. Let's take a look at what I do have going on the card. And I put, again, because this is flat, I put everything right in the root directory, but there's probably no reason why it can't be placed anywhere else. And there is a special thing that you need to do in order to build this boot.scr. Let me show you how this boot.scr looks, because there's not anything special going on. Make that a little bit bigger so it's easier to read. All right, so there we are. This gunk at the front is from the make image command that you get from the U-Boot Tools package out of the standard package repositories that are there. And then the rest of this is just plain old shell script type stuff. I have an echo command. I have a setenv command, which if you look is very close to what was copied out of the Raspberry Pi's command line.txt. There's hardly any changes at all to this, I don't think. Yeah, at the end of it, I did fbcon equals rotate:3, and that's how we get it to turn in text mode so that the text is flowing from top to bottom like it should, top to bottom, left to right like it should, instead of sideways. And then this fat load, this is loading the Z image, which is the Xiegu Linux 589 kernel, I believe, off the top of my head. I think it's 589. And then this is the device tree blob for the internal system on a chip development board that's running on in there. And then this command instructs, the first two fat load commands instruct where to load it into memory. And then this boot Z says to boot a compressed image that you find at 46 million, whatever that number is, with the device tree blob that you find at 49 million, whatever that number is. And then the only other thing that we had to do to the generic Raspberry Pi image was to go into the Etsy folder and edit the FS tab and dereference the fancy names and put in the real names, and then it booted up. But like I said before, I can't recreate this image. I've tried to clone it, I've tried to make it by hand, I've tried to go through all the steps I went through before, I tried different partition types, and nothing is working out. I can boot into the firmware that is on the radio and then type the commands in manually, but that will boot it. But obviously that's not the goal. What the goal that I have in mind for this is you put in an SD card and you boot it in and play radio all day long with our custom firmware, and then you turn it off and take that SD card out and you're back to a bone stock radio. So no harm done to the internal device, ready for firmware updates. You're not burning through flash writes on the internal MMC. Everything's good to go with just a simple reboot. So leave some comments down below. There are links to the GitHub repo. There are links to Toad Discord, where we're talking about this in the X6100 Shenanigans channel over on the Toads Discord. Everybody's welcome to join in, and I'm looking forward to your feedback. There is a video right over here that I think you would like to see next. Thanks for being awesome.